Okay, another question here. Um, so a closed container of a cylinder. A closed container consists, of a cylinder of diameter 18 centimeters and height 20 centimeters on a hemisphere. Okay, and I think all that's in the picture. Find the volume of the hemisphere in terms of pi. Okay, so volume of a hemisphere, we are going to want the formula and tables book. We're going to want volume and surface area. Now, there is no hemisphere, but there's a sphere. So the volume of a sphere you can see here is 4 over 3 pi r cubed. Right. So so that gives us 4 over 3 pi, and the radius of the hemisphere, you can see it in the picture. The radius of the hemisphere is going to be the same as the radius of the cylinder because it's sitting perfectly on top. So that's going to be 9 cubed. Okay, so I'm typing into my calculator 4 over 3, shift pi, bracket 9 cubed. And it says in the question in terms of pi, so I'm going to use the one on my calculator that has the pi in it. So 972 pi, and that's going to be a volume, so centimeters cubed. So that is the volume of the sphere, because there is no technical formula for the volume of a hemisphere, so we do need to remember to divide by 2. So 486 pi centimeters cubed is my final answer for the first part. Okay, the second part. Find the volume of the whole container. Okay, so obviously we have the volume of the, I'll scroll down. We have the bottom of this bit, so we just need to do the volume of the cylinder and then add them together. So I'm going to go get the volume of the cylinder, which is here. So here's the cylinder. It says cylinder. It gives you area and it gives you volume. So volume is pi r squared h. So put that here. So the pi is pi. The r, what was it? 9. And then the height is 20. So 9 squared 20. So shift pi, bracket 9 squared, bracket 20, and that is 1620 pi. So then to get the entire container, we just add the 2. So 1620 pi plus 486 pi is 2106 pi, and again centimeters cubed. Alright, and the last part. If the container is half full of water, find the height of the surface of the water. Okay. Right, so H is in the picture. Okay, so a couple of things here. The hemisphere is full. So we can take that bit off. I assume it's half of the, yeah, it looks like half of the total container. So if the container is half full of water, find the height. Okay, so the available volume in the container is 2106 pi centimeters cubed. Yeah? So that means divided by 2, 1053 pi centimeters cubed has water in it. Yeah? Half. Right. I can then subtract the volume of the hemisphere, 486 pi, because the hemisphere is full. So that leaves me with 567 pi centimeters cubed of water in the cylinder. Does that make sense? So the total available volume in the sorry, I'm going to use words now. The total available volume in the container is 2106 pi. It's only half full of water, so 1053 pi centimeters cubed of water. And then the hemisphere is full, so 486 of that, 486 of the 1053 is in the hemisphere. So that leaves 567 pi centimeters cubed of water that's in the cylinder. And then we want to know the height of that. Yeah? So I wrote up above that the volume of a cylinder is, what was it, pi or squared h, pi or squared h. The volume of water that we're dealing with is 567 pi in the cylinder. And then the radius of the cylinder is 9 squared. And I know that we know the height of the cylinder, but we don't know the height of the water in the cylinder. And that's what this is about. It's about 567. Yeah, so h we don't know. So we have a pi on both sides, so they can cancel. So we have 567 equals 81h. And then we want to isolate the h. So we divide by 81. Oh. So that gives us 7 centimeters high. Okay, so again, hope that is helpful.